In this question, we will calculate the pressure exerted by the cylinder which is placed on the flat surface. Okay, and this cylinder is hollow from inside, whereas the thickness of this cylinder is X as written here, and it is much smaller than the R. So it is comparatively smaller. So now what is a pressure? The according to the definition of the pressure is the force exerted. Which force exerted? The force that is exerted normally perpendicularly on the surface divided by per unit area. So how much force is exerted by this cylinder? As you see in this question, it is written here W, which is the weight of the cylinder. Okay, so that's simple, that the pressure exerted is equals to the W weight over area. Now the tricky part is to understand what area do we have to take. Should we take the area pi r square, which is the cross sectional area of the whole cylinder, or should we take the pi x square, or should we take some other thing? All right, let's see this thing with the help of a diagram. So if you see in this diagram, this is the area which is actually applying the force on the flat surface, which we have to calculate. But if you calculate this complete area, all right, so that will be pi r square. So students, its area is pi r square, all right, the area of a total cylinder. But if you see this distance, which is radius of the cylinder, whereas if I find this distance, which we see in the diagram, is x. All right, why I'm doing this? Because r minus x is the length which you, if you closely look here in this diagram, then, so students, this is r minus x. I hope you understand. So if I find the area of this part, which part? This one. You see this? And if I subtract it from the total area, pi r square, then I will be able to find out that area which is applying force on the flat surface. So now students, you can see more clearly, this is the 1 r minus x, and what will be its area? Pi into r minus x whole square. So now the thing is that we have the two areas, the one that is a total cross sectional area of the cylinder, and the one that is actually the cross sectional area which is not taking part. All right, so we have to subtract. You understand? If I put this here, so I have to subtract it from this, then I will get the area which is applying the pressure. So required area is the pi r square minus pi into r minus x whole square. All right, so now we will solve it, and so pi r square minus pi, you can apply the formula, and when we will open it, so it will be r square plus x square minus 2rx. Okay, so multiplying it inside, it will be pi r square minus pi x square plus 2r pi x. So students, we can cancel this one. All right, and you remember we had said in the start that x is smaller than the r, much smaller. It means that we can make it 0, we can assume it's 0 because it's not taking part, because x square will make it further small. You understand? We can say that the x square will be approximately 0. So this is basically 2r pi x, by the way. All right, if you understand that this area which we have calculated, this one is 2r pi x. So that's why our final answer is equals to w over 2r pi x. So that must be A.